In this clip, we're going to use a graphing calculator to find points of intersection graphically as opposed to doing it by hand, like in the last clip. And there are two additional things that I'm also going to stress in this clip. The first thing is, when you're using your calculator on the AP exam, you're always going to want to be in Radian mode throughout the entire year. I can't think of one instance when you're going to want to be in degrees. So point number one is put your calculator in Radian mode and leave it there. So radians is where you want to be. That's number one. Point number two has to do with rounding. For the AP exam, you need to round any decimal to 3 decimal places. Now, when you do this, you have a choice. You can either truncate or you could actually round. So I'm going to give you an example. Suppose you did a calculation on your calculator and you ended up with an answer of 0.3456 Well, if you decided to truncate, that means you're just going to take those first 3 numbers after the decimal place and just call it a day. So that would be 0.345. And this would be a perfectly acceptable answer for this decimal response on your calculator. If, on the other hand, you chose to round, you'd have to look at the 4th value after the decimal point and decide accordingly whether to leave it alone or round up. So another option in this case would be 0.346. Either one of these examples would be acceptable. I'm now going to show you how to use the calculator to solve something like this and find the point of intersections if they exist. What I'm going to do is I'm going to call the left-hand side of this equation y1 and the right side of the same equation y2. I'm going to go to the y equals screen and I'm going to enter under y1 2x cubed minus 4x. For y2, I'm going to enter x minus 1. And now I'm going to press zoom 6, which gives me a standard viewing window. So I see a wiggly looking graph and I should see a line. Now I see that the line and the wiggly looking graph cross 3 times, though the window is really not zoomed in very well to see that. So I'm going to use zoom option 1, which is zoom box. I really like this option. The cursor always starts off in the center at the origin, and I'm going to move this cursor to represent the corner of, or one of the corners of this box. And then I press enter, and what I do is I drag and I create a box that is inclusive of these points of intersection. When I press enter again, that is going to become my new window. So there is a zoomed in portion of the wiggly graph, and there's the line. So I can clearly see that there are 1, 2, 3 points of intersection. So to do this on the calculator, we're going to use second, trace, option 5, which is intersect, and I'm going to move the cursor like a video game. It's very fun, over to that first point of intersection. Once it's over there in that general area, I'm going to press enter 3 times. 1, 2, 3. And it's going to tell us the point of intersection. Now, even though they give us an ordered pair, all I'm really concerned about is the x value, and that is negative 1.672 or 3. It doesn't matter. So I'm going to go over here, negative 1.673. So we have negative 1.673. Now let me call the calculator back up, and I'm going to do the same thing again, second trace 5, and now I'm going to go to the one in the middle. Again, only concerning myself with the x value, I have 0.203. And finally, for the last one, over to the right, I end up getting 1.469 or 1.470. 1.470. So these 3 represent approximate solutions to this equation. I'm going to repeat the process for problem number 2. I'm going to call this y1, and I'm going to call the right-hand side y2. Now notice they give us an interval here, and that's because this trig function goes on forever, as does this line here. and there would be infinitely many solutions. So by giving us a specified interval, we can zero in on the specific answers that we want. So I'm going to call the calculator up again, and now I'm going to move it over here. And I'm going to the y equals screen, and I'm going to clear my existing entries. Because I'm dealing with trig, I just want to double check to make sure that my mode is in radians, and I am, so I'm good. So I'm going to put in cosine 3x, and I'm going to put in the opposite or negative. Okay, so now I'm going to adjust my window so that I have the same interval that they'd like us to look at. So I'm going to go from 0 to pi over 2. And you'll notice that converts to a decimal. That's 1.5. So maybe I'll go by 0.5s. I'll see 3 tick marks or so. And I also know that the amplitude of a cosine graph is from -1 to 1. So maybe -2 to 2 will be sufficient. So here's a portion of cosine 3x. Here's -√3 over 3. And they seem to intersect twice. Second trace 5. Here's the first one. 1, 2, 3. This looks like it's about 0.729. 0.729. And then if I repeat that process, I get 1.366. So these are the approximate solutions to this trig equation using the calculator. So just to emphasize, always make sure your calculator is in Radian mode, and when dealing with decimals, you have a choice of either truncating at 3 decimal places or rounding at 3 decimal places. At this time, you should go and do the problems that are associated with clip number 7.